All right, just 3 more examples because I would like us to be comfortable factoring perfect square trinomials when there's a fraction involved. And while it may look menacing, the strategy is going to be exactly the same. So let's take a look at our first example. Y squared plus 5y plus 25 over 4. Well, it's already in standard form, so let's go ahead and look at our first term and our last term and see if they look like perfect squares. So y squared, definitely a perfect square. That is the square of y. Now 25 over 4, is that a perfect square? Is there anything we can multiply by itself to get 25 over 4? Absolutely. If we multiply the fraction 5 over 2 by itself, we will definitely get 25 over 4. Awesome. And so we're thinking that maybe we could actually have a perfect square trinomial on our hands. Maybe we've got the perfect square trinomial y plus 5 halves, quantity squared. And if you want to check to make sure it works, check this out. We know that if we were to multiply this by itself, we would get a trinomial of this form. So we get a y squared. At the end, we would get 5 halves quantity squared, which is 25 over 4. And in the middle, we should get 2 times y times 5 halves. Well, 2 times 5 halves is 5. Times y is 5y. So indeed, this is the correct factorization. So look, not so bad. Let's do some more. In our second example, already in standard form, let's take a look at the first and last terms. M squared, is that a perfect square trinomial? Absolutely, that is the square of m. Is 1/4 a perfect square? 1 over 4, that's definitely a perfect square. That's what we get when we multiply 1 over 2, or 1/2 by itself. Check it out. All right, so along with this negative 1 times m in the middle, we're thinking that this guy very well may be m minus 1/2 quantity squared. Let's confirm. If we were to multiply this binomial by itself, it would look kind of like this. So we would get an m squared, okay. We should get a negative 1/2 quantity squared, which is 1/4, we got that. And in the middle, we should get negative 2 times m times 1/2. Well, 2 times 1/2 is 1. 1 times m is m. Do we have a negative m? Absolutely. So, hey, it worked. Again, not so bad. All right, last one. Holy cow. G squared plus 3 halves g plus 9/16. I mean, this looks really menacing. But the strategy remains the same. G squared, is that a perfect square? Absolutely, that is the square of g. 9 over 16. Is there anything we can multiply by itself to get 9 over 16? Absolutely. If we multiply 3 over 4 by itself, we indeed get 9 over 16. So we're thinking that this trinomial very well may be a perfect square, and it might be the perfect square of g plus, that plus gives it away, 3/4 quantity squared. And in this case, to confirm that we actually factored this correctly, I'm going to actually go ahead and multiply out g plus 3/4 squared, or g plus 3/4 times itself, g plus 3/4. And I think we're going to end up with g squared plus 3/4 g plus 3/4 g plus 9/16. Let's see, 3/4 g plus 3/4 g is 6/4 g plus 9/16. Oh, and 6 over 4, that reduces to 3 over 2. And so indeed, we end up with the product that we hoped we would, and we determined that this is indeed the correct factorization for this gnarly trinomial. So I hope you enjoyed, guys, and I hope you found it helpful.